Good morning, students. So far, we have completed different topics in Unit 1 and Unit 2. From today, I'll start with Unit 3. In today's session, I will explain the concept of polymorphism and how polymorphism can be achieved in C++ through the concept of operator overloading. In our last session, we learned with some example program the concept of dynamic constructor and the purpose of destructor. We know that a destructor is a special member function in C++ which destroys an object, which is complementary to a constructor which allocates a memory for that object. So in general, constructor creates an object and destructor destroys an object. In today's class, we will be learning the basic concept of polymorphism and how polymorphism can be achieved in C++ using operator overloading concept. At the end of today's session, you will be in a position to understand what do you mean by polymorphism and how polymorphism can be implemented in C++ using operator overloading concept. As the name indicates, poly means many and morphism means forms or appearance. So in general, polymorphism means different forms. In our introductory lecture, we learned about the basic concept of object-oriented programming. Some of the basic concepts of object-oriented programming are objects, classes, encapsulation, inheritance, polymorphism, and dynamic binding and message passing. So polymorphism means it is the ability of either a function to perform different tasks depending on the argument. So in C++, what happens is same function can be used for varieties of tasks in the same program. In that case, the different version of the same function should differ in either the number of argument or the data type of the argument. So same function, we can use it for different purpose in the same program by changing either the number of argument or the data type of the argument. So that concept we call it a function overloading. It's also called a function polymorphism. And another option in C++ is in similar to your function operator, same operator, we can use it for different tasks. In that case, the performance of the behavior of the operator depends on the operands. In function, the polymorphism or the function overloading is a concept where same function is used for different purpose depending on the argument. Similarly, same operator can be used for different purpose by depending on the operands. So function overloading and operator overloading are the two ways of achieving polymorphism. Polymorphism, again, they are classified into two types. If it is possible to achieve polymorphism, then in that case, during compilation time, it's called as static polymorphism. So polymorphism that is resolved during compilation time is known as static polymorphism. Example, function overloading and operator overloading are the examples of static polymorphism. The polymorphism that is resolved during runtime is called a dynamic polymorphism. So in C++, dynamic polymorphism can be achieved using virtual function. Anyway, I will explain the concept of virtual function in later stages. So basically, polymorphism is ability of either a function or an operator to perform differently. If the function performs different tasks, depending on the argument or the data type or the number of argument, it's called as the function polymorphism or function overloading. The same operator performs different tasks depending on the operand, it's called as a operator overloading or operator polymorphism. So let us study what do you mean by the basic concept of operator overloading. Operator overloading is a unique characteristics of object-oriented programming. So it is the ability or the power or the strength of an operator to perform or behave differently depending on the operands. Then what do you mean by performing different? For the same operator, if you give one category of operand, it gives you it performs differently. For the same operator, if you give the different type of operand, then its behavior changes. So this feature allows the programmer to use the operator on user-defined data type in the same manner as built-in data type. For example, we know the purpose of plus operator. What is the purpose of plus operator? For the plus operator, if the both the operands are integer type, it gives you a sum of two numbers. For the same plus operator, if you give two complex number, in that case, in C++, same plus operator gives you the sum of the two complex number. The difference between the first and the second case is, in the first case, the both the operands belongs to basic data type. The second example, both the operands are not basic data type because they are object, because C1 is one object, C2 is another object of the class complex. In that case, C1 plus C2 gives the sum of two complex number. Similarly, if there is a class called string and S1 and S2 are the two objects, in that case, S1 plus S2 gives you the concatenation of the two strings. So now we can see that in all these three examples, operator remains as plus. In the first case, it gives you sum of two integer. In the second example, C1 plus C2, it gives you the sum of two complex number where the C1, C2 are the object. The third example, S1 plus S2, it gives you concatenation of two strings. So in here, what happens is same operator, they have used it for three different purposes. So that is the ability of the operator. So C++ never differentiate whether the operands you are giving for that operator is a basic data type operator operand or a user defined data type. For example, in the first example, A plus B, A is integer, B is integer, means both A and B are what a basic data type. The second example, C1 plus C2, C1 and C2 are the two objects of complex class, means here C1 and C2 are not basic type. C1 and C2 are user defined data type. Similarly, in the third example, S1 plus S2, again S1 and S2, they are not basic data type. They are not int, not float, nor char. They are string type. So string is a user defined data type. So in that case, same, the compiler never differentiate whether the operand you are supplying for that operator is belongs to a basic data type or a user defined data type. Its behavior remains the same. So the compiler will not differentiate. So if you in the C++, same operator like plus, minus, star, etc. can be used for different purpose. So by overloading the operator, we are giving additional meaning to the operator. The basic purpose of plus operator is for what? Addition of two numbers. Same operator, we are giving additional power to add two complex number. Similarly, same plus operator, you give additional strength to add two strings. Similarly, minus, you can use minus operator to subtract two integer, to subtract two float value, to subtract two complex number, etc. Star, you can use it for addition of two matrices. You can use it for product of two complex number, or we can use it for multiplication of two integer number. Similarly, greater than operator can use it for comparing two integer or comparing two float type or comparing two dates where dates are not basic data type. So if D1 and D2 are the two objects of date class, mean in that case, same greater than operator can be used to check whether the first date is greater than second date or not. So we are giving additional meaning to the existing operator. So another feature is whenever you overload an operator, suppose if you use the plus operator in the same program for both addition of two integer and for addition of complex, we are using the plus operator for adding two objects. In that case, the original meaning of the plus is not altered. Originally, what is the meaning of original meaning of plus operator? To add two integer or to add two float. When you use the plus operator in some program to add two complex number, its original meaning is not altered. So the operator never loses its original meaning when it is overloaded. We are going to understand these concepts when we start writing some simple programs. But all the operator available in C++ cannot be overloaded. Some operator we can overload, some operator you cannot overload. For example, plus operator, we can load overload. Overload means you are giving addition. You can use the plus operator to add two integer, or to add two float, or to add two complex number, or to add two string. Similarly, greater than operator can be used to add two, can be used to compare two integer, or to compare two string, or to compare two character, or to compare two dates, or to compare two matrices. So some operators are can be overloaded like plus, minus, star, greater than, less than, equal to. They're all these operators can be overloaded, but there are certain exceptions. Some operators you cannot overload. Some of the operators which you cannot overload in C++ are scope resolution operator, size of operator, dot operator, and conditional operator. So these 4 or 5 operators, there is an exception that you cannot overload them. You have to use it only for their purpose. For example, scope resolution operator, the purpose is to what? To access the global value of the variable inside a particular function, or to define a member function of a class outside the class. You can use it only for that purpose. You cannot change its meaning. Whereas plus operator, star operator, you can change the meaning to behave differently. Whenever you are overloading an operator in C++ program, you have to write a separate function called operator function. For example, in the program, you are using plus operator to add two complex number and star operator to find the product of two complex number. Means you have to write two operator function. First function changes the or gives the strength for plus operator to add two complex number. Similarly, the other function gives the strength for the star operator to multiply two complex number. Suppose you want to compare two dates. In that case, you can overload the greater than operator. In that case, you have to write one operator function. So depending on which operator you are overloading, corresponding operator function you have to write. But operator function is also a special type of function. That's a member function only. So a member function, in case of C++, your operator function can be made either normal member function, or you can write that function as a friend function also. So operator function need not be member function. It can be either a member function or it can be friend function. But there's a slight difference in making the operator function either a member function or a friend function. So for example, you are overloading a binary operator like plus. In that case, if you are writing the operator function as a member function, then you are overloading plus operator, it's a binary operator. In that case, for that operator function, one argument is enough. But it's the same operator function. If you are writing it as a friend operator function, in that case, to overload a binary operator, two operands are required. That means for any of the binary operator to overload, if you are writing a operator function as a member function, one argument is enough. And if you are writing it as a friend function, then two arguments are necessary. Similarly, if you are overloading a unary operator, if you are writing operator function as a member function, no argument is necessary. But if you are using the operator function as a friend operator function, then one operand. For unary operator, for operator function 0, for friend operator function 1. In case of binary operator, for member operator function one argument, for friend operator function 2 arguments are necessary. So what is the syntax of operator function? The general syntax of operator function is, first you mention the return type, then you write the class to which the operator function belongs, scope resolution operator, then the keyword called operator, followed by the operator you are overloading. For example, I'm using the plus operator to add two complex number. So in that case, when you add two complex number, what is the return type? It is another complex number. So the return type place you can write complex. The class name is also complex. Scope resolution operator, which is operator overloading here plus. And since it's a binary operator, one object you can give complex C1 or you can give complex C2. Similarly, we are overloading a greater than operator to compare two dates. Whenever you give two dates, the system compares the two dates using greater than operator. The first date is greater than second date, it returns 1. The first date is not greater than second date, it returns 0. In this case, the return type is 1 or 0 means int. So in that case, the operator function looks like the return type is int, class name, date, scope resolution, operator, and you are overloading which operator? In the place of OP, you can write greater than symbol. Then this is also a binary operator, means you can give either one date, either you can give date D1 or you can give date D2. Then you write the content of that function. So here, return type specifies the type of the value returned by the function, and OP is the operator to be overloaded. So with here, so far you understood what do you mean by polymorphism. Polymorphism is the ability of either a function to behave differently depending on the arguments, or the operator to behave differently depending on the operands you are specifying. So with the operator overloading concept, for most of the existing operator, you give them additional strength. For example, plus operator, the original strength is to add two integer. Same plus operator, you add additional strength so that you can use the same operator to add two complex number. Similarly, greater than symbol, the general purpose is to compare two integers or to compare two real numbers. For the same greater than operator, you add additional strength so that same operator can be used to compare two dates. Similarly, you take an operator called plus plus. What is the purpose of plus plus? The purpose of plus plus operator is to increment an integer number. Same plus plus operator, you give additional strength so that when you use that plus plus operator with a object called date, it gives you the next date. So if you give the date as 23, 10, 20, 20, then if you it is stored in an object called D1. If you write D1 plus plus, it gives you the next date. So operator overloading and function overloading are called as operator polymorphism and function polymorphism respectively. These are the two different ways of polymorphism. But polymorphism, the two broad categories are one is static polymorphism, other one is dynamic polymorphism. In case of static polymorphism, the polymorphism is resolved during compilation time. In case of dynamic, it is resolved during runtime. And whenever you are overloading any operator, equivalently, you should write one function called operator function. That function could be either a member function or it could be a friend function. So the difference is, in case of overloading unary operator, for member operator function, no argument is necessary. Whereas for friend operator function, one argument is necessary. In case of binary operator overloading, for member function, one argument is enough. For friend operator function, two arguments are necessary. So for example, if in the same we are writing a program to add, multiply, subtract two matrices mean, then you have to overload how many operators? You have to use plus operator to add two matrices. You have to use minus operator to find the difference of two matrices. You have to then you use the star operator to find the product of two matrices. In that case, you are overloading three different operators. Plus, minus, star mean equivalently. You have to write three operator function. Similarly, if you want to compare two dates, whether first date is greater than the second date, or whether the first date is less than the second date, or whether the first two dates are equal. In that case, you have to overload greater than operator, you have to overload less than operator, you have to overload equals, double equals operator also. You have to again three operator functions. So depending on which operator you are overloading, equivalently you should write one operator function. So with this, I will conclude today's class. In today's class, we have understood the basic concept of polymorphism and how polymorphism can be achieved by overloading different operators. We'll take up in the next class. So these are some of the review questions. Explain the concept of polymorphism. Distinguish static and dynamic polymorphism. Static polymorphism, both operator overloading and function overloading comes under the category of static polymorphism. Dynamic polymorphism, we can achieve it in C++ using virtual function. Anyway, that will be our next class and next discussion topic. What is operator overloading? Operator overloading, the definition is that's all. It's the ability of an operator to behave differently depending on the operands. And what are the advantages? Mean you are giving additional strengths to the existing operator depending on the operator. In that case, the original meaning or original strength of the operator is never lost. Same operator in some other program, you can use it for its original purpose only. For example, if you have overloaded the plus operator to add two complex numbers, in the next program, you can use the plus operator to add two integer again. Name the operator which cannot be overloaded. It's a very, very important concept because for 2 marks question, usually this type of question will appear. Some of the operator we cannot overload them are question mark, colon, that is conditional operator, then scope resolution operator, dot operator, etc. Some simple multiple choice questions or true or false questions on today's topic is operator overloading is a form of static polymorphism, true or false? True. Operator which cannot be overloaded. Plus plus operator we can overload. Anyway, there is a program how to overload plus plus operator to find the next date that I will explain in my next class. Plus operator we can overload. You can use the same plus operator to add two integer. I can use the same plus operator to add two matrices or to add two complex number. Conditional operator cannot be overloaded. The correct answer is C. To overload a binary operator, operator function, not a friend operator function, normal operator function takes dash argument, one argument. Correct answer is B. Ability of an operator to perform differently depending on the operand. It's called as a operator overloading or overloading. Dynamic polymorphism is achieved through operator overloading. Operator overloading and function overloading are the two categories of static polymorphism. It can be achieved through virtual functions. The correct answer is C. With this, I will conclude today's session. From next class, I will explain some simple example overloading different categories of operator. So we have one separate program where we are overloading plus, minus, star and slash operator to perform arithmetic operations on two complex numbers. And there is another program where we are comparing two dates by overloading greater than operator, less than operator, and double equals operator. There is a program to find the concatenation of two string by overloading plus operator and comparing two string using double equals operator. And one more program, how to find the next date. If you are finding the next integer, means suppose n is 10. We want to find the next integer, means n plus plus. So there you are using the plus plus operator. Same plus plus operator. You can apply it on the objects called date object to find the next date. So these are some of the practical program that I'm going to explain in my next class. Thank you.